We're going to build a customizable Brickout game in this series while learning how to program with pygame. There are a lot of generalizable concepts here, including event handling, object-oriented programming and design, graphics, and GUIs, plus tons of computational problem solving that will be more fun than frustrating because we're building a game. Please program along with me. It's the best way to learn. This is Maggie from Design Code Debug Repeat. Let's get started. I do assume you already know Python in this series and that you have a version of Python 3 installed. If not, I recommend you work through my series on learning Python by building a text adventure game, linked here, or one of my other introductory Python courses, and then come back. Your first step is to install pygame because it does not come with your Python installation. Go to Pygame's website and follow the instructions there for installing pygame. To test your installation, run idle and type import pygame and enter, and you should get a friendly message, or at least not an error. If you get an error, go back to the command prompt, Google any error messages you got when installing, and apply the suggested fixes. Once your installation is working, create a new script. Our game will have this structure. First, pygame setup, then game setup, and then a game loop. The game loop will process the player's commands, do background processing, and then draw the current state of the game and show it to the player. For pygame setup, type import pygame at the top of the script, and then pygame.init, open close paren. We can also add pygame.display.init, open close paren here. It is not strictly necessary for this program, but it's a good idea. That's it for that step for now. For game setup, this is where you will create a window for your game to run in, create and load in assets like images and sounds, and create a clock to regulate the speed of your program. To create the window, type screen equals pygame.display.set_mode, and now we pass in the width and the height of the window in pixels as a tuple. We'll pass in 600, 800. Make sure you have two sets of parentheses, one set for the function argument, and then one set around the tuple. To give your window a title, type pygame.display.set_caption, and then in parentheses, pass in the string you want for your window title. I'm putting Brickout 1.0. To create the clock, type clock equals pygame.time.clock, open close paren. Now, for the game loop, let's create a loop control variable, running, and set that to true, and then write while running, and inside the loop we'll regulate timing, get events, do background processing, and draw. To regulate timing, we'll write clock.tick 30. Without this, your game might run too fast or too slow, depending on your computer. To process events, we'll use a for loop for e in pygame.event.get. This will allow us to process every event currently in the event queue. An event has a type, so we'll check to see if the player clicked the close box, and we'll set running to false if they did. That looks like if e.type equals pygame.quit, running equals false. And then at the end of the game loop, but not inside the event loop, we update the display, pygame.display.flip. And after the game loop, we'll want to release our resources, so we'll write pygame.quit. Let's run that. Okay, I get a black window with the title Brickout 1.0. And if I click the close box, the program quits. Not very exciting, but it is the framework into which we will drop all kinds of cool stuff. Before we add something interesting, I'd like to annotate the variables and just give a quick overview of what these data types are. Anything you don't recognize from your knowledge of Python is part of pygame. So I'll put a comment in for annotating variables, and then for variables we have screen, clock, e, and running. Screen is a surface, so I'll annotate that as pygame.surface. All drawing in pygame happens on surfaces. The surface that we get from invoking pygame.display.setMode is a special surface that will be shown to the player. All other surfaces that we make are going to be components that we can layer onto the surface to build what the player sees. Clock is an instance of pygame.time.clock, and as I said before, that regulates the game so it runs at a consistent speed. We won't need to do anything else with that beyond what we already have. E is an event, which I will annotate as pygame.event.event. This is an object which contains information about an event. An event is created when the player does something, such as move the mouse, click a mouse button, press a key, or close the close box of a window. We can respond to those events in our game, for example by changing playing mode or moving a player character. We'll do that before the end of this video. And running is a bool. Okay, let's do something fun and add a little square with some personality to this program. If I want to create something that I'm going to draw to the screen, then I should create a surface for it. Drawing will be easier if each individual element has its own surface and we layer those surfaces before showing them to the player. I will annotate a variable, square of type pygame.surface, and this one I'll create with a surface constructor. I will do this in the game setup area after I create the clock. I will write square equals pygame.surface, and we put a size in, just as we did for the screen. Let's make it 50 by 50. As with when we created the screen, that's a tuple, so enclosed in parentheses. When we create a surface, by default, it's black. We'll learn lots about surfaces in the next video. For now, we'll just fill our square surface with white. Square.fill, open paren, 255, 255, 255, close paren, close paren. The color argument is also a tuple, so enclosed in parentheses. Feel free to play around with colors and make your square whatever color you like. Now, we've created the square surface, but to make it visible in the game, we need to blit it to the screen. We do this in the game loop, after the event loop, but before we flip. Each time through the loop, we want to do any processing, like moving NPCs or calculating collisions, between the event loop and the flip, and then we draw those changes so the player can see them and flip. So I will type screen.blit square, and then let's put it somewhere in the top left, say 100, 100. The blit command is the one we use to layer our surfaces onto the screen. It copies the bits, or pixels, from one surface to the other. The surface before the dot, in this case screen, is the one being copied to. The first argument, in this case square, is the one being copied from, and the second argument is the coordinate of the top left of the blit. When I run that, we can see the square at coordinate 100, 100. Now, the personality I'm going to give my square is a little jittery. And to manifest that personality, I'll have the square shake a little bit and move off screen. So let's look at how motion is accomplished. Each time through the loop, we draw the square to the screen and then flip the display. The screen is the canvas on which we build up a snapshot of the current state of the game for the player. And once it's ready, we flip, and the new screen is shown to the player. Let's see what happens first if I move the square toward the edge of the screen a little bit more each time through the loop. I'll annotate some variables for the x and y coordinates, and I'll make them integers. These variables will hold the current position of the square, so I'll initialize them to 100, 100. And each time through a loop, I can add a little bit to them, say 2, and blit the square to that new location. And the next time through the loop, I'll be adding 2 more, etc. So technically, if I want the square to be first blit to 100, 100, I should initialize those variables to 98, 98. Either that or update the coordinate variables after the blit. Be sure to replace the hard-coded 100, 100 with x and y. Let's run that. And uh-oh, that's not quite right, is it? The square is moving off the screen, but it looks like it's leaving a trail. And this is because we're not erasing the prior square before drawing a new square. So we're just adding to our snapshot instead of creating a whole new snapshot of the current state of the game. What we'll do is create another surface called background up in our setup area, and we'll make that the size of the whole screen. Each time through the loop, I'll blit the background first and then the square. Blitting the background to 0, 0 will effectively erase our prior snapshot. So when we blit the square, it will be the only thing on the screen. And remember, a surface defaults to black, but you could fill the background like we did with the square if you wanted the window to be a different color. Just don't make it the same color as the square or you won't be able to see the square. Let's run that. Okay, now I see a square moving slowly to the bottom right of the screen. It doesn't look nervous, though. It looks determined. Let's make it a little nervous by giving it a random quiver. I'm going to import the random library at the top of this script. And each time I change x and y, I'm going to add an adjustment of a random number between -3 and 3. This will have the square moving in the same direction over time, but it will add variation. Sometimes it might wiggle up or to the left, and sometimes it might lurch a little further to the right or down. So it'll give it a nervous feeling. Generating a random number looks like random.randint -3, 3. The two arguments are min and max, and the random number will be between min and max, inclusive. Let's run that. Now it jiggles away. It doesn't look uncomfortable enough, though, so I have a solution, a simple way to fake motion blur, or instability. Normally, we will blit each element once per game loop. But to add to the uncomfortable feeling of the square, I'm going to blit it twice, once in its current location and once in its new location, giving it a motion blur effect. So once before I set the new coordinate, and once after. I think this will make it look more unsettled. Make sure you blit both of them after you blit the background, otherwise you'll erase some of your work. Let's run it. Yes, an unsettled square slowly exiting the screen. Let's see if we can add some code so the player can keep it in the window. In the event loop, we are handling a pygame.quit event. We can add handling for another event, like a mouse click event, by writing elif e.type equals pygame.mousebutton_up. And then under that, what can we do? Event objects have information about the event, such as the location of the click. So we could pull that out of the event and assign it to the x and y coordinates, pulling our little square back into the window where the click is. We can write x, y equals e.pos. I'll run it. Now we can keep the jittery square from exiting the screen by relocating it to the position of the click. So that's it. Our first Pygame game, and the framework for everything we'll build from now on. In the next video, we'll dig into both surfaces and events some more. I have some homework for you, but don't worry, it's fun. Before the next video, play with the colors. Fill both surfaces with different colors. Since we've imported random, you can even randomize the colors. Each component, red, green, and blue, can be any number between 0 and 255. Then try adding another square to the game. You could start by moving both squares in the same way, but once you've got that working, give your second square a different personality and different behavior. You could even give it a mad scientist ability, like the ability to teleport randomly within the window. If you get stuck or want to share your successes, drop a comment below. I look forward to seeing you in the next video, and as always, have fun and keep coding.